In this video, we will look at the sum and difference identities for the sine, cosine, and tangent functions, and we will also derive them. Now, we'll begin with cosine. Consider 2 points on the unit circle. Let P be the intercept of a terminal side of angle alpha. So I'm going to draw my unit circle at the very top. Let's say there's our unit circle. So we're going to say point P corresponds to an angle alpha, and point Q corresponds to an angle beta. Now, without loss of generality, we may assume that alpha is larger than beta. So actually, the way I drew it here, I made my beta larger, so I'm going to switch these. P, Q, that's beta there, and this is alpha here. Now, without loss of generality simply means if beta were larger than alpha, the derivation would be exactly the same, right? Just switch the alphas and betas. Now, note that the measure of angle POQ is alpha minus beta. So this is O right here. That's the origin, right? So it is the alpha minus the smaller beta, right? So that is, let's use a different color. So that is this angle right here. That's alpha minus beta. Now define the point A to be the intercept of a terminal side of angle alpha minus beta, and B to be the point 1, 0. Okay, so 1, 0 would be right here, so there's B. And then the point A would be some point that makes an angle alpha minus beta. Since the triangle POQ is the rotation of the triangle AOB, the distance from P to Q is the same as the distance from A to B. What we'll do is we'll now look at both of these distances. So distance from P to Q. By the distance formula, it'll be the quantity of cosine of alpha minus cosine of beta squared, plus the quantity of sine of alpha minus sine of beta squared, all square rooted. Right, remember, distance formula is the square root of x1 minus x0 squared plus y1 minus y0 squared, square root of that, right? Now, if we expand both of these out, we'll get this. What we'll do now is we'll group this and this. Then we'll group those two. Right, but now each of these terms is 1 by the Pythagorean identity. And we can also factor out a negative 2 from these last two terms. And so that leaves us with this. All right, so keep this in mind. Let's now look at the distance from A to B. Again, using the distance formula, is the quantity of cosine of alpha minus beta minus 1 squared plus the quantity of sine of alpha minus beta minus 0 squared, and then the square root of all that. Once again, expanding, we'll get this. We can now group these two terms together. Well, this sum here is 1. Add that to this one, we get 2, and we're left with this. Now, the distances must be equal, so we set them equal. Right, remember, this was the distance from A to B. This was the distance from P to Q here. Well, we can square both sides. These 2's wind up canceling out. We can then divide by negative 2's. So we're left with this. And there we have it. This is our distance formula, or I'm sorry, the difference formula for cosine. I recommend that you write this down on a separate sheet of paper and keep it handy. Right now, cosine of alpha plus beta, well, that would just be the cosine of alpha minus negative beta, right? So what we're trying to do now is come up with some formula. Well, we can write it as a difference. So using the difference formula we just derived, we get this. Now, cosine is even, sine is odd, so using that, we get this. Now this is the sum formula for cosine. Again, I recommend you write this down under where you wrote the difference formula. Let's now apply these formulas. So first, let's go ahead and calculate the exact value of cosine of 13 pi over 12. Well, what we can do is we can write this as the cosine of 15 pi over 12 minus 2 pi over 12. The idea is to try and write this as either a sum or difference of two known angles. Right, so 15 pi over 12 would be 5 pi over 4. 2 pi over 12 is pi over 6. These are both known angles. Now we can go ahead and apply the difference formula. That'll give us cosine 5 pi over 4 times the cosine of pi over 6 plus the sine of 5 pi over 4 times the sine of pi over 6. Right, so the cosine of 5 pi over 4 is negative root 2 over 2. The cosine of pi over 6 is root 3 over 2. Sine of 5 pi over 4 is root 2 over 2. And sine of pi over 6 is 1/2. Now we multiply the first two terms, we'll get negative square root of 6 over 4 plus, now multiply the second two terms, square root of 2 over 4. And so this simplifies to the square root of 2 minus the square root of 6 all over 4. So this is our exact value of cosine of 13 pi over 12. Let's now look at the cosine of 75 degrees. Again, the idea is we want to write 75 degrees as either a sum or difference of known angles. Well, we know 45 degrees, and we know 30 degrees, and notice that 45 plus 30 is 75. We can now use the sum formula. We write this as cosine of 45 degrees times the cosine of 30 degrees minus the sine of 45 degrees times the sine of 30 degrees. Cosine of 45 degrees is square root of 2 over 2. Cosine of 30 degrees is square root of 3 over 2. Sine of 45 is square root of 2 over 2. Sine of 30 is 1/2. Multiplying this out, we'll get square root of 6 over 2. I'm sorry, over 4. Minus square root of 2 over 4. Simplifying, we get root 6 minus root 2 all over 4. So this is the exact value of cosine of 75 degrees. Okay, now let's look at the sine function. So we'll begin with sine of alpha minus beta. Well, using the cofunction identities, we can write this as cosine of pi over 2 minus the angle, so minus that alpha minus beta. Now let's group pi over 2 minus alpha together, and we'll be left with then plus beta. We can now use the sum formula for cosine. And now, once again, using cofunction identities, we get this. Right, so cosine of pi over 2 minus alpha is sine of alpha. Sine of pi over 2 minus alpha is cosine of alpha. So this is the difference formula for sine. Well, just like we did with cosine, for the sum formula, sine of alpha plus beta, just write it as a difference, sine of alpha minus negative beta. Then we can apply the difference formula we just derived, and then use even and odd properties of sine and cosine, and we get this right here. So this is the sum formula for sine. And again, I would recommend you write these down where you're listing all of your trigonometric identities. Now, just as we did with cosine, let's go ahead now and apply these. So we'll start by looking at the sine of 15 degrees. The idea is always the same. We want to write this as the sum or difference of two known angles. Well, 15, we know 45, we know 30, so we can write this as 45 degrees minus 30 degrees. This will give us, using the difference formula, sine of 45 degrees times the cosine of 30 degrees minus the cosine of 45 degrees times the sine of 30 degrees. Sine of 45 degrees is the square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Cosine of 45, square root of 2 over 2. Sine of 30 is a half. We'll wind up with the square root of 6 over 4 minus the square root of 2 over 4. This is then just square root of 6 minus square root of 2 all over 4. All right, let's now look at the sine of 75 degrees. Well, we're going to use the same two angles we used in the previous example, except this time we're going to add them. And we can now use the sum formula, and we get sine of 45 times cosine of 30 plus cosine of 45 times sine of 30. And without reinventing the wheel, we can go back here and look, okay, so sine of 45 times cosine of 30 was root 6 over 4. Cosine of 45 times sine of 30 was root 2 over 4. Their differences now, we are adding them. So we get root 6 over 4 plus root 2 over 4. And we get the square root of 6 plus the square root of 2 all over 4. Finally, we will consider the tangent function. So let's look first at tangent of alpha minus beta. Well, remember, tangent is sine over cosine. This allows us to use the difference formula for both sine and cosine. Now we have to do some mathematical black magic here. Divide both the numerator and denominator by the same term, and equality is still maintained. So let's go ahead and divide both numerator and denominator by cosine of alpha times cosine of beta. What we can now do in both numerator and denominator is write these as two separate fractions. Right, so it'll be this first term over this. Now we can write each of these as two separate fractions. Right, combine the first term with the denominator and second term with the denominator. And do that for the bottom fraction as well. Doing so will give us this. Now what we can notice, cosine betas drop out here, cosine alphas drop out here. That whole fraction was 1, and then we're left with being able to write this as the product of two fractions, namely those and those. Now that will give us this. And this is the difference formula for the tangent function. Now, as we did with sine and cosine, we can go ahead and write the sum as a difference. So the tangent of alpha plus beta is tangent of alpha minus negative beta. Then we can use the difference formula that we just derived. Now, tangent is odd. So using that property, we can write this, and this is the sum formula for tangent. We will conclude this video now with one last example. Find the exact value of tangent of 5 pi over 12. So again, the idea is we want to write 5 pi over 12 as either the sum or difference of known angles. We can write 5 as 9 minus 4. So we can write this as 9 pi over 12 minus 4 pi over 12. And these are known angles, right? Because 9 pi over 12 will simplify to 3 pi over 4. 4 pi over 12 will simplify to pi over 3. Now we can apply the difference formula. We'll write tangent 3 pi over 4 minus tangent pi over 3 all over 1, plus tangent 3 pi over 4 minus tangent of pi over 3. So tangent of 3 pi over 4 is negative 1. Tangent of pi over 3 is the square root of 3. We factor out that minus in the numerator, we can write negative root 3 plus 1 over negative root 3 plus 1. Now we can apply that negative to the denominator, and we can write root 3 plus 1 over root 3 minus 1. And this is our exact value for tangent